All right, so I'm making this video so that you can access answers to all these questions and see the work that you need to be able to do for the test. This is the closure for Chapter 7, so I'm going to skip the summarizing and go straight to the what I've learned. These are the questions, and all these types of questions, these concepts here, are what you're going to find on quite a bit of the test. Some of the test will, of course, be review, but here are the questions we're looking at. 7-131 asks, Ava is saving money for a trip. She's able to save $75 a week. Okay, so I'm going to go ahead and just write that down really quick. Ava she's going to be green, and she's saving $75 per week. So I'll say per 1 week. All right, so there's Ava. Now, Annie is saving 9,000 kronas each week. So I'll put Annie in pink. And Annie is at 9,000. I'm not sure what the symbol for krona is, so I'll just put K per week. Remember, we talked about this in chapter 7.2, somewhere around there. The word per, P-E-R, can also relate to division. So when you see per, you want to think about division, and you also want to think about fractions. And remember, fractions and division is the same thing. Okay? So these are the two things, and we need to see which is greater, $75 a week or $9,000 or 9,000 kronas per week. And we know from the problem that about 500 kronas is $4. So this is a rate problem, all right? We've got to figure out if we've got 500 kronas equals $4. The first thing you want to do is, there's several ways to tackle this, but think about your unit rates, right? Unit rate, which is a rate based off of the number 1. So that's for the unit right there. So you're comparing something to 1. So this is 5,000 kronas for $4. Can we make this, how many kronas are in $1? Can we make this a unit problem or a unit rate? And we can. If you want to get $4 to turn into 1, you multiply it by its multiplicative inverse, 1/4. Okay? Because 4 times 1 is 4. 4 divided by 4 is 1. Now, we can't change this equation here. We change something on this side. We have to change something on this side too. So we can do the exact same thing over here, 1/4 as well. So what we're given now is, we said that this was $1. And 500 divided by 4 is, I'm just going to check this on the calculator, 125. So 125 kronas is the equivalent of $1. Okay? So then this becomes a question of, well, if Eva is saving $75 a week, and Annie is spending 9,000 kronas a week, and there are 125 kronas per dollar, how many dollars are in here? Well, we want to know how many times 125, or $1, goes into 9,000 kronas. So it would be 9,000 divided by our 125 right there. And that equals 9,000 divided by 125 equals 72. So now we've translated this from kronas to dollars, and she's saving $72 a week. So the person who's saving the most is going to be Eva, and her $75 per week. So that's question 1. Question 132 says a breakfast cereal is made of oats, nuts, and raisins. The advertisement boasts that 30% of the cereal in each box is raisins. So what portion of each box is not raisins? Well, maybe the word problem is confusing you, but it is a simple subtraction problem. We've got 100% is the entire box. And so that's the whole box. And it's a 30% are raisins. So everything but raisins would be the difference between 100% the whole box and 30% the raisins. And that's just a subtraction problem. The answer, 70%. So that would be the answer for A. For B, it's asking if each box contains 8 cups of cereal, how many cups of raisins are in each box? Draw and label a diagram to represent the problem. Okay, so the diagram is going to help you visualize what we're looking at here. So I'm going to draw as straight of a line as I can. And the total is going to be 8 boxes. So without even thinking too much about this diagram, I'm going to go ahead and label that 8 boxes. And then it says, how many cups of raisins are each box? Draw and label a diagram to represent the problem. We're going to have 70% over here to be, so we'll just say this is regular cereal. That's 70%. And this 30% is going to be raisins. And so we want to know what this little section here, this 30% of the cereal is. And 30% of, well, much like we had before up here where we said per is the same as division, well, the word of is multiplication. So let me write that down. When we think of, we think of multiplication. So in this case, I want to know what 30% of 8 cups, I think I said boxes back there, yeah I did, 8 cups is. And so we would do 30% of 8 cups, that would be 30% times 8 cups. So of course you can't put 30 into the calculator and do 30 times 8 because that would give you a ridiculous amount of raisins. We want to know 30%, which is the same as 30 over 10, or 30 over 100, which is the same as 0.3. So you would do 0.3 times 8 cups. And so 0.3 times 8 equals 2.4 cups. And that's how you'd answer that one. Okay. Oh, and C, if box contains 2 cups of nuts, what percentage of each box is nuts? So this is a little backwards one. First we figured out that 30% of 8 cups is 2.4. Now we want to figure out how many cups the whole box is if we have 2 cups. So I'm going to do this down a little bit more. So I have 2 cups of raisins. And that is, which is 30% of something, of the whole box. So here's another keyword, is the same as equals. Here's our multiplication. Here's an unknown number, which I shouldn't have crossed out. And here's our known number. So we can take this sentence, 2 cups is 30% of the box, and translate it almost directly to a math problem. So I'm going to make this pink, the 2 cups of raisins. I'm going to make the unknown number blue, and I'm going to make the 30%, we'll keep that green. So 2 cups is equals 30%, or 0.3, of, is multiply, and the unknown variable, the box, we'll just do in blue the letter B. Okay. And then from here you want to use your inverse operations. If you can, multiply the letter B, the unknown number, by 0.3 to get 2, then you can divide it by 0.3 to get rid of that right there. We want to get rid of this. So I'm going to divide the same thing by 0.3. And then I can't do something to this side unless I'm going to do it to this side. And so 2 divided by 0.3 6 2/3. 6 2/3 equals B. And that makes kind of sense. 8 cups was 2.4 cups of raisins, so you would expect 2 cups of raisins to be slightly less, and 6 2/3 is a little more than 1 cup less. So that makes sense there. All right, let's move on to the next question. Erase a little bit over here. All right, so the next question. Mel's Grocery is selling 3 cans of soup for $5. Use this information to complete the table below, then graph the relationship between the number of cans you could buy and the price. So here's our graph right here.
Let me do a search for an answer to
So
$5.
I do not know why my phone is talking to me. So here we are. We have, let's see here, 0 cans is $0. That makes sense. 3 cans is $5. Now, of course, we could be looking at rates, but there probably with problems like this, you can find a simpler way to do it than comparing rates. For example, 6 is twice as much as 3. So it would make sense that the price for 6 cans would be double the price of 3. So double of that is 10. Now in this case, they're not giving us the amount, they're giving us the price, 15. Well, the information that we need is already right here because we know that $5 worth of cans is 3 cans, $10 worth of cans is 6 cans, 15 is 5 plus 10. So $5 plus $10 is $15. It would be 3 cans plus 6 cans is 9 cans. Now 45, we know to get from 15 to 45, we have to multiply by 3. 15, 30, and then 45. So if we multiply 9 by 3, that will be the number of cans, right? It's $15 for 9 cans, so 3 times that is $45, so 3 times 9 is 27. And then finally 30, we can do that same sort of logic. For 3 cans is $5, 30 is 10 times as much as 3, so we're going to buy 10 times as many cans, which would be 50. I don't know how this 1 showed up there. Oh, well, anyway, so that was 50. We said this was 9 right here. We said this was 10. And we said this was 27. And that's how you do that. All right, now I encourage you, let me see here. I would encourage you at this point to look back for 134 at the videos about division. But I'm going to be using several different methods to get through these problems. So let's start with 3/7 divided by 2/3. So we have here, do the first one in pink, 3/7, and then divided by 2/3. All right, this we want to solve. The algorithm would be to rewrite this. The first fraction would stay the same, but then that second fraction, you want to flip it over. And then notice instead of division, I did multiply. This is the algorithm, flip and multiply. You take the second fraction right here, you turn it into its reciprocal, and then you multiply it right there. So now this becomes a very simple problem of 3 times 3, the numerator is going to equal 9. 7 times 2, the numerator is going to equal 14. And that's it. That's all there is to it. The next method, I'm going to use a different one. 1.2 divided by 0.04. All right, so again, I will do 1.2. This is A, by the way. B here. 1.2 divided by, my other one here is 0.04. Turn this into fractions because this is, I do not like dealing with place values with division and things like that. I would much rather see some fractions. So this is going to be equivalent to saying 12/10 divided by 4, oops, wrong color, 4, and the 4 is in the hundredths place. Yeah. For this one where I got 12 tenths, I have the 2 in the tens place, and then this 1 over here in the ones place. And so we know that it's going to be more than 1, and there's going to be 2 tenths plus this additional 1, so that's 12 tenths there. And so I am going to use the common denominator method, since that lends itself really well to it, to get a common denominator between all these guys. We can keep the 4 over 100 as it is, because we know that 10 times 10 is 100. So I'm going to multiply this by 10, and I also have to multiply this by 10 in order to keep them the same fraction. So it would be 120 over 100. And it's still a division problem. Sometimes people forget. I saw some people think that this would become a multiplication one, like this flip and multiply, but that the multiplication flip only works for this one, and we'll see why in a second. With the common denominator, the nice thing is that we can now get rid of the denominators, and it just becomes 120 divided by 4, which I know that 120 divided by 2 is 60, and 60 divided by 2 is 30. And that's our answer right there. And then for C, 8 2/3 divided by 4 1/2. So we'll do 8 2/3 divided by 4 1/2. Now, again, we want to see some improper fractions. These mixed fractions are a pain to work with. And I think the only reason why they put them there is so that you can practice getting out of them, because they don't really serve very much good except for seeing how it relates to a whole number. Sometimes it's hard when you have these fractions like this to see how it relates to a whole number, but when you get that whole number there, it's clear that this is 8 and then a little bit. But for calculating, they're a waste of time. So we're going to turn this 8 into, let's see, there are 8 groups of 3/3, so that would be 8 times 3 is 24. So this is going to equal 24 plus 2 other thirds, so that's going to be 26 thirds. And it's still a division problem. That still hasn't changed. This 4 1/2 right here is going to be 4 groups of 2 over 2, so that's 8 plus 1 is 9 halves. And so now we have a nice division problem. No common denominators, so we can't do anything with the common denominator method. But we're going to use the supergiant 1 method here, and you're going to look at the end and see how it relates to why we multiply when we flip and multiply. So we're going to rewrite this whole problem now as a fraction. So let me see here. I'm going to grab the pink here, and we're going to do 26 over 3. And then we're going to divide by, and in green we are going to say 9 halves. Okay? And now here's the big thing. To simplify, we want to get rid of this denominator down here, because this is not a simple fraction, which is what we want to end up with. So if we can get rid of this denominator, then we're in great shape. And we can do so by turning it into 1. So I'm going to, or by turning the denominator into 1. And so what can I multiply 9 over 2 by to become 1? Well, I multiply it by its inverse, its reciprocal, 2 over 9. Okay, because then we get 9 times 2 is 18, and 2 times 9 is 18. And so we're going to have 18 over 18, which equals 1, right? So that's going to equal something over 1. Now, again, just like we did a little while ago here, you have to multiply. You can't multiply this math problem by anything but 1, or you're going to screw it up. So you multiply it by 2 over 9 to get rid of this guy, but that means you also have to multiply the top of the fraction by 2 over 9 as well. 2 over 9. So this right here, you can tell equals 1. 2/9 over 2/9. These are exactly the same. So this whole thing is our supergiant 1. Didn't mean to drift there, sorry. That really doesn't look like a 1. I'm just going to get rid of that altogether. So 26 times 2 is 52. And then 3 times 9 is 27. And then I can take 52 over 27 as my final answer right there. I don't know if 52 is going to be divisible by anything else. We'll just leave it as that. That's just fine with me. All right, so that is how to tackle 134. 135. Maureen and Michael want to make cupcakes for their teachers. They have 6 tubes of frosting, and each cupcake requires 2/7 of a tube of frosting. How many cupcakes can they make? Show how you know. Well, this kind of should remind you of those problems that I did up on the board where I had all those illustrations to help you think. So just looking for a quick little illustration. 1 cupcake. So there's our little cupcake here. You like that? A little birthday candle on it. 1 cupcake equals 2/7 of a tube. 2/7 would be about here. And so how many cupcakes can you make if you have 6 tubes? So 1, 2, 3, 4, 5. Just drawing this terrible diagram right here makes you think it's going to be quite a bit. You could get how many cupcakes out of each tube? Well, 3 and a little bit. So we would have 3 times 6, 18 cupcakes plus a little bit more. All right, so how are we going to set this up? Well, we have they have 6 tubes. Okay, so you want to know basically how many of these little 2/7 pieces fits into all 6 of these tubes. That'll tell you exactly, because each one of these 2/7 is going to be 1 cupcake. So making 2/7 equal 1 cupcake, you can figure out how many 2/7 go into the tube, and you'll know how many cupcakes. It'll be a direct relationship. However many 2/7 of a tube you can fit into these 6 is exactly how many cupcakes you'll make. So 6 divided by 2/7. Okay? Pick a method. You can do common denominator, you can do supergiant 1, you can do flip and multiply. I'm going to do supergiant 1 because I think that's what people need the most practice with. So we're going to multiply it by a version of 1 that will get rid of this denominator. It's got to be the reciprocal. It's got to be 7 over 2. But this all has to equal 1, so you also have to have the numerator be 7 over 2. So we know that this is going to equal 1 because 2 times 7 is 14, 7 times 2 is 14, 14 over 14 is 1. 6 times 7 is going to be 42. And this is really 6 over 1. So 1 times 2 is 2. So the answer is 42 over 2, which equals 21 cupcakes. And that seems like a reasonable number. We said it was going to be slightly more than 18. 21 is definitely slightly more than 18. All right, 137. Oh, no, sorry, 136. This is one where we want to create a math magic trick using these expressions. So let's see if I can get, no, I can't do a smaller thing. So x we said was add, oh no, I'm sorry. X we said was pick a number. And then we multiply by 3. And then we add, this is a really straightforward one, that's nice, add 27. And then to get from 27 to 21, we subtract 6, And then here's the interesting one, to get from 3x to plus 21. Notice that we need to get both terms down. So if we were to just subtract something, we'd be able to subtract from the constant here, but not from the variable and the coefficient. This term wouldn't be touched if we just subtract a number from it. But we can see that there are factors going on in each term, and you can eliminate factors all at once by doing a division of the whole thing. This has a factor of 3. That's very clear. It's the coefficient, 3 times x. 21 also has a factor of 3, but it's hidden. What if I rewrote the problem as 3x plus 3 times 7? Then it's very clear that this term has a 3 and this term has a 3. And if I were to divide this whole thing by 3, then look what I would end up with. If I divided 3x by 3, I would get x. If I divided 3 times 7 by 3, or 21 by 3, I would get 7, x plus 7. So that's here, divide by 3. And then finally, subtract original number. So the only thing to be worried about when you see these things is when you see two terms change at the same time. In this case, only one term was added. 27 was added. In this case, only one term changed, 27 to 21. In this case, two terms changed at the same time. That's a hint that this is going to be a division or multiplication problem. And it's going to, you want to look for some common factors between the two terms that have changed. So in this case, they both changed by a factor of 3. And that's how you do that. 137, we're getting close to the end. Thank you for sticking with me, for those of you who did. When algebra tiles are grouped in sets, as shown below, they can be written in two different ways. Write two equivalent expressions that represent these collections of algebra tiles. Okay, so here in A, we have 3 sets of variables, or 3 variables, x, x, and x. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 singles. So there's really two ways to think about this. I say in class you can think of them vertically. You have 3 variables, which would be 3 times x, plus you'd have all these guys here, which would be, we counted as 12, 3x plus 12. That's one way to think about it. Another way to think about it is you have this horizontal grouping right here, x plus 4, and then you notice you have 3 identical groupings of each one. So you're multiplying everything by 3. 3x plus 12, and 3 times x plus 4 is the same thing. And if we remember our distributive property, we can see that they're equivalent because we're going to multiply this 3 into, we'll distribute it to the x and to the 4. We distribute it to both terms inside, which is going to give us 3x plus 12. Oops. I don't know why that happened. So you can see they're equivalent. So it's just two ways of thinking about it. Are you thinking of it as 3 groups of x plus 4? Or are you thinking of it as 3 variables plus 12 singles? We'll do the same thing here. In blue, we're going to look at it vertically. 2 x's plus 1, 2, 3, 4, 5, 6 ones. Or you can look at it horizontally as a group of 1x plus 3, and seeing that there's a total of 2 groups altogether. Both of those are going to work for you. Finally, 7-138. Use the rectangle below to complete the following problems. X plus 5, x plus 5, those are your lengths. X is your height. I'm going to do this over here. Let's see here. So, do I have a drawing tool? I do not. So I'm just going to have to draw a lousy rectangle. All right. And we have x plus 5 here. We have x here. And the first question is asking us, write 2 different variable expressions to represent the perimeter of a rectangle. And this is kind of fun. The thing to remember is that you can add x's together. When you add an x plus x, it's going to be 2x. And of course, if you add a 5 plus 5, it's going to be 10. So what we have here, I'll finish writing all these, x plus 5 and x. You're going to have, let's do these top ones here. Well, we'll just do x plus 5. I think it might help if I do it in different colors. I'm going to make this one pink. I'm going to make this one blue. And I'm going to make this one green. So we did our first x plus 5. And then we're going to do plus x. So we got that one and that one. Now we're going to do plus x plus 5. And then we're going to do plus x again. And so now we want to simplify this down. We have 1, 2 5s, so that's going to be 10. And then how many x's do we have? 1, 2, 3, 4 x's. So it's going to be 4 times x. So these are 2 different ways to write the same perimeter. All right, it could be, you could just think of it as adding all the sides together, or you have 4 x's, 1, 2, 3, 4, and then an additional 10 right there. What is the perimeter of the rectangle if x is 7 feet? Well, you would just replace x with 7. So it would be, I could put it all in here, but just to be faster, I'm going to do 4 times 7 plus 10 equals 4 times 7 is 28 plus 10 is 38 feet. And then I'll go ahead and do the challenge for you. If the perimeter is 26 inches, what is the value of x? So we go back to this problem right here. We say that 4x plus 10, this is our equation, and this kind of shows the very end, 7.3.4. We can use equations to find missing variables. This is what we're going to do. We're saying that 4 times this missing number plus 10 is going to equal, and I think they said it was 26 inches. 26 inches. So whatever the variable is, if I multiply it by 4 and then add 10, I'm going to have 26. So you want to think about some inverse operations here. What if I took 10 off of the perimeter? This is our known perimeter. What if I took 10 off of that perimeter? Well, I would be left with 4x on this side, and I took 10 off, so that would be 16. Okay? So now I know that, I already took that 10 off, so now I know that x plus x plus x plus x is 16. And if all of these are equal, they're all x, then I have 4 times x. And to figure out the, so to figure out what one of those is, I would divide it by 4. You could kind of think back, it's similar to how we did unit rates. If we want to get rid of a number and just make it 1, you just divide it. So then we do 4, 16 divided by 4, x equals 4. There's your challenge problem right there. That's it, ladies and gentlemen. For those of you who stuck with me, kudos. I look forward to seeing how you do on the test, and let me know if you need any more help. Thank you so much.